Namaskar dosto, my name is Yashasvi Verma and today in this video we are going to discuss biomedical waste management system. So first of all let's see what is the definition of biomedical waste. Biomedical waste or hospital waste is a kind of waste containing infectious or potentially infectious material and is generated from biological and medical sources and activities such as diagnosis, prevention and treatment of disease. Waste generated in hospitals, there is an estimate that waste which is generated in hospitals varies from half kg to 2 kg per bag. We have two types of waste. One is general waste, which is non-hazardous, whose proportion is up to 80%, and another is biomedical waste, which includes infectious waste up to 10% and chemical and radioactive waste up to 5%. Now let's see that what are the sources from where biomedical waste is generated. So number one source is operation theatre, another source is labor room, neonatal care, laboratory, injection room, wards, OPDs, blood storage facilities, X-ray centers, stores, kitchen. Biomedical waste which is generated affects all. No one is unaffected from it. If we see the steps of waste management, so the first step that comes is segregation, another step is collection and storage, and the third step is transportation, and fourth step is treatment and disposal. We have various types of color-coded dustbins in which we have to discard all the waste. Infectious waste is discarded into red, yellow, and white or puncture-proof container, whereas non-hazardous or non-infectious waste is generally discarded in green or black colored dustbins. During collection and storage, we we should collect and store biomedical waste in a proper way so that no one gets injured. Safe transportation is very important. We should never carry a waste in open bags and never carry it through crowded areas. Always carry the waste in secure sealed containers bag. Treatment and disposal of waste depends on the type of waste. We will learn about that in a few minutes. Hazards associated with biomedical waste. Inappropriate and inefficient disposal of biomedical waste can lead to infectious hazards, malignancies, malformation, and environmental pollution not only to the current generation but also for future generations. The various hazards are hazards from infectious waste. This is a component of hospital waste that produces maximum hazard. Pathogens in infectious waste may infect healthcare workers by entering through ingestion, inhalation, or direct skin-to-skin contact and can cause various types of infections such as gastrointestinal, respiratory, skin infections, etc. Hazards from infectious showers lead to transmission of blood-borne viruses, hepatitis B, C, and HIV. Hazards from chemical waste. They include laboratory reagents, disinfectants, and waste with high content of heavy metals. Example, mercury from broken thermometers. Most chemicals are toxic, corrosive, explosive, and flammable. Can cause various physical injuries including chemical burns. Pharmaceutical waste. It includes expired, unused, and contaminated drugs, vaccines, sera, etc. Exposure to these agents may cause several adverse effects depending upon the nature of pharmaceutical waste. Hazards from cytotoxic waste. Cytotoxic drugs used in the treatment of cancers and autoimmune disorders are extremely hazardous to the environment and human health owing to their mutagenic, teratogenic, or carcinogenic properties. Hazards from radioactive waste. They include materials contaminated with radionuclides, They are produced as a result of procedures performed by radiology and nuclear medicine department. They are geno- they are genotoxic in higher doses and can cause severe injuries including tissue destruction, necessitating an amputation of body parts. Waste management hierarchy. Waste management hierarchy is largely based on concept of 3R, namely reduce, recycle, and recover. If none of these method is available, then the last method opted is disposal. Prevent and reduce. The most preferable approach is to prevent or reduce the production of waste as far as possible. Reuse and recycle. The next best option is to reuse the waste such as or after recycling. And the third R means recover, where practicable recovering waste items for secondary use can be done. It is of two types: energy recover, whereby waste is recovered to fuel for generating electricity or for direct heating. Waste recovery is a term used for compositing of organic waste matter to produce compost or soil conditioner which can be used in agriculture. Treatment. Waste that cannot be recycled or recovered can be subjected to treatment by various methods. Treatment is also necessary for the biomedical waste before sending for recycling or recovery, as these wastes are potentially infectious. This is usually carried out by the autoclave or microwave. It involves disposal of waste in landfills or dump yards. This is the least preferable option among all the waste management strategies. Steps of biomedical waste management includes waste segregation at the point of generation into color-coded container or dustbins, pre-treatment of laboratory liquid waste, transport of waste from generation site to the central storage area of hospital, transport of waste from central storage area to common biomedical waste treatment facility, treatment or disposal within 48 hours of generation. Importance of segregation. Segregation plays a very important role in preventing needle stick injury, which transmit hepatitis B or HIV. Segregation also helps us in reducing the production of carcinogens, which are produced if plastic items are thrown into yellow bag. Securements. All the bags used in waste collection need to be sealed once they are filled to three-fourths of the capacity. Bags and containers should be labeled properly and the date with date and place. The laboratory liquid waste should always be pre-treated either with chemical 1 to 2% hypochlorite or autoclave before segregating into appropriate containers. So here you can see the logos which are used on dustbins. This sign denotes biohazards. This is biohazard symbol and this is cytotoxic hazard symbol. These symbols will be present on dustbin. Now we are going to discuss latest biomedical waste management rules, including the amendments of 2018 and 2019. Through this chart, we are going to learn which type of waste is to be discarded into which color of dustbin. So first of all, we have yellow colored dustbin. In yellow colored dustbin, the first thing is human anatomical waste, animal anatomical waste. All the human and animal anatomical waste should be discarded in yellow-colored non-chlorinated bags and which is further treated with incineration, plasma pyrolysis, deep burial method. Soiled waste is also segregated in yellow dustbin which is further treated with incineration, plasma pyrolysis, deep burial, autoclaving or hydroclaving plus shredding or mutilation. We will learn about all these techniques after few minutes. Fourth thing is expired and discarded medicines, pharmaceutical waste, cytotoxic drugs. These should also be discarded in yellow colored containers with non-chlorinated bags with cytotoxic label. We will discard all that pharmaceutical waste in yellow dustbin which will have this type of logo on it. You can see here that this yellow dustbin has this type of logo, which means we can discard human anatomical waste, animal anatomical waste, soiled waste, but we cannot discard pharmaceutical waste into this. We need a yellow dustbin with this type of symbol in which we can discard pharmaceutical waste. And now, how we will treat this pharmaceutical waste, we will send back it to manufacturer or combined biomedical waste treatment facility for incineration. Cytotoxic drugs at temperature more than 1200 degrees centigrade. Another thing which is to be discarded in yellow colored dustbin is chemical soiled waste. These are treated with incineration or plasma pyrolysis or encapsulation. All these methods will be discussed after few minutes. Now you have to remember one thing, that chemical liquid waste such as discarded disinfectants, infected body fluids and secretions, liquid from housekeeping related activities are not to be discarded in yellow dustbin. These should be discarded into separate collection systems which leads to effluent treatment system and not to be discarded into yellow bag. These collection systems are further treated before mixing with other wastewater. For easy understanding and practically, you should have a separate collection system in which you should dilute that particular disinfectant by adding water, and that mixture will be further treated before mixing with other wastewater. Another type of waste, which is this discarded linen, waste contaminated with blood and body fluids, mask, cap, gown, and shoe cover, should be discarded in non-chlorinated yellow plastic bags, suitable packing material, and which will be further treated with non-chlorinated chemical disinfection followed by incineration or plasma pyrolysis. Microbiology, other clinical laboratory waste, blood bags, live attenuated vaccines should be discarded in autoclavable safe plastic bag containers and which are pre-treated to sterilize with non-chlorinated chemicals on site as per NACO or WHO guidelines. After yellow dustbin, now we will discuss about the waste which are to be discarded into red dustbin. So infectious plastic waste, disposable items such as tubing, bottles, intravenous tubes and sets, catheters, urine bags, syringe without needles and fixed needle syringes are and vacuum with their needle cuts, gloves, plastic apron and goggles should be discarded in red colored non-chlorinated bags or containers, and they will be further treated with autoclaving, microwaving, hydroclaving plus shredding. Mutilation, sterilization, shredding can also be used for their treatment. The treated waste is then sent to authorized recyclers for energy recovery. Another type of container, which is white or puncture-proof container, is used to discard sharps like needle, syringe, fixed needles, needles from needle tip cutter or burner, scalpel, blades, or any other contaminated sharps used or discarded. This container should be puncture-proof, leak-proof, tamper-proof containers, and they are further treated by autoclaving, dry heat sterilization, followed by shredding or mutilation or encapsulation in metal container or cement, concrete or sanitary landfill or designated concrete waste sharp pits. Another type of dustbin is blue color dustbin. In blue color dustbin, we usually discard glasswares and metallic body implants. Glasswares like broken or discarded and contaminated glass, including medicine vials and ampoules, except those contaminated with cytotoxic waste, microscope slides. Metallic body implants like dental implants, other body implants and plates. These containers should be puncture-proof and leak-proof containers, and they are further disinfected by soaking the washed glass waste after cleaning with detergent and sodium hypochlorite treatment 1 to 2%, or by autoclaving, microwaving, hydroclaving, and then it is sent for recycling. Till now, all the dustbins which we have discussed contains infectious waste. For non-infectious waste or non-hazardous waste, till now there is no specific color coding for general waste in hospitals. It depends on local policy, hospitals, that what color code they choose for general waste. For example, JIPMER uses black bag for general waste. But your hospital can also use green color coded dustbin for general waste. Ideally, most of the hospitals that I have seen in my career, I have seen that most of the hospitals uses black color code for general waste. Now we are going to discuss treatment and disposal methods. As per the mandate of Biomedical Waste Management Rules 2016, the final disposal and recycling must be performed at common biomedical waste treatment facility. Only when there is no biomedical waste treatment facility within 75 km, the hospital can create its own disposal facility. The following are the methods used for treatment or disposal of biomedical waste. So the first method is incineration. Incineration is a high temperature, from 800 to 1200 degrees centigrade, dry oxidation process that reduces organic and combustible waste into non-organic incombustible matters, resulting in a very significant reduction of waste volume and weight. Incineration is usually done for those waste that cannot be reused, recycled, or disposed in a landfill site. For example, a human and anatomical waste, microbiological waste, and solid non-plastic infectious waste. Halogenated plastics such as PVC should never be incinerated as it generates furans which are carcinogenic. Another method is autoclave. Autoclaving is a thermal process where steam is brought into direct contact with waste in a controlled manner and for a sufficient duration to sterilize the waste. It is mainly used for the treatment of infectious plastic and sharp waste. Chemical disinfection: a chemical such as hypochlorite 1 to 2% is mixed to waste which result in disinfection. It is more suitable for liquid waste such as discarded blood and body fluids and also for hospital sewage. Effluent treatment plant: the liquid waste generated in hospital, if mixes directly with groundwater, it can create significant health risk. Therefore, it is first subjected to chemical treatment and then is drained into effluent treatment plant. Effluent treatment plant removes the suspended solids and organic matters in wastewater and then disinfects the wastewater with hypochlorite and finally drain the water to municipal drainage. Another technique is microwaving. Microwaves are radio frequency waves used at a frequency of 2450 MHz. They produce friction of water molecules which generates heat. Large size microwaves are used for disposal of biomedical waste, mainly infectious plastic and sharp waste. Another method is hydroclaving. Hydroclaving is low temperature steam sterilizer involving steam treatment with fragmentation and drying of waste. It breaks up the waste into small pieces of fragmented material, thus obviates post-cycle shredding. Unlike autoclave. Shredder. Shredding is a process by which waste are de-shaped or cut into small pieces so as to make the waste unrecognizable. It helps in prevention of reuse of biomedical waste and also helps to reduce the waste volume. Another method is deep burial. Deep burial is a pit dug about 2 meters deep. It needs to be half filled with waste and then recovered with lime within 50 centimeters of surface before filling the rest of the pit with soil. The groundwater level should be a minimum of 6 meters below the lower level of deep burial pit. Sharp pit: a sharp pit is constructed within the hospital premises, provides an alternative method for disposal of sharp waste generated from the facility. Here you can see that this is a sharp pit. Here is a funnel-like structure through which we can store sharps into these concrete blocks. Encapsulation: Encapsulation methods involve filling the container with waste, adding immobilizing material, and sealing the containers to prevent the access to unscrupulous activities. The process uses cubic boxes made up of metallic drums, which are three-quarters filled with sharps or chemicals or pharmaceutical waste, and then filled with a medium such as plastic foam, cement mortar, or clay material. Another method is inerization. The process of inerization involves mixing waste with cement and other substances before disposal to minimize the risk of toxic substances contained in the waste migrating to surface or groundwater. It is especially suitable for pharmaceuticals and for incinerated ashes with a high metal content. Another process is plasma pyrolysis. Plasma pyrolysis uses ionized gas in the plasma state to convert electrical energy to temperatures of several thousand degrees using plasma arc torches or electrodes. The system provides high temperatures combined with high ultraviolet radiation flux, which destroys pathogens completely. Now to dispose cytotoxic drug waste: expired cytotoxic drugs to be returned back to the manufacturer or supplier or biomedical waste treatment facility for incineration at 1200 degrees centigrade or encapsulation or plasma pyrolysis at 1200 degrees centigrade. Till now, all these methods used were for infectious waste. For general waste, disposal of general waste: they constitute a large component of hospital waste. They are not biomedical waste. Their disposal can be carried out by several strategies. Compositing: it is the decomposition of organic matter by microorganisms in warm and moist environment. Waste to energy: by various methods such as incineration, pelletization, biomethanation, etc. Recycling of waste: landfills in dump yards. Thank you for watching my video. I hope you have learned something new from my video. If you liked my effort, don't forget to like, share and subscribe my channel. Thank you.